In a communications nerve center in Colorado, a nationwide alert warns that a massive explosion 93 million miles away will soon have a profound impact on planet Earth.
This is the Space Environment Services Center in Boulder, Colorado. We have an alert. An X-ray event was observed today at 2150 Universal Time, and we do expect protons to
The
follow.
power of the sun is beyond the grasp of human imagination. A single solar flare can release the energy of 100 million hydrogen bombs, enough to fuel the North American continent for 100,000 years. Earth emerges from the dawn of time, a planet solely dependent on the sun. The giver of life, we have come to rely on the enduring strength of its heat and light. But scientists around the world are now uncovering secrets that may well shatter age-old beliefs in the sun. Their discoveries have reopened a century-long debate over its influence on planet Earth. In a California library, a modern solar physicist seeks clues to the sun's behavior in forgotten books, scientific observations set down over 300 years ago that are still vital today. In Arizona, scientists have developed an unusual technique to reconstruct a history of climate. Under a microscope, a telltale pattern may link the sun to the unknown fate of a lost civilization. Halfway around the world, in Australia's outback, a geologist has made an extraordinary find. Ancient rocks may actually be a diary of the sun, a rare glimpse into its prehistoric past. In Alaska, cameras of exceptional power aim skyward to capture an unprecedented look at the mysterious northern lights, the aurora borealis. 20th century technology has now revealed the source of this astonishing phenomenon. For 4,000 years, mankind has watched and worshipped the sun. Now we are beginning to know the true dimensions of its influence on planet Earth. Enter now the invisible domain of the sun. Embark on a journey in time and space through the awesome world of the solar sea.
Annenberg Media.
Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
According to Hindu legend, the first primordial sunlight fell on the river Ganges, and the universe was born. Each morning at Benares, India's faithful still gather to mark the event. To keep the sun from burning up, water is sacrificed and prayers offered. Vishnu is the reigning sun god, but India's gods are many. Bhaskar is the creator of light. Dinakar, the maker of day. Jivana, the source of life. Since the dawn of human history, man has stood in awe of the sun's consummate power over the earth. Carefully aligned on a north-south axis, the pyramids of ancient Egypt still reflect the first light of the morning sun. The Egyptians found order and meaning in the sun's daily cycle. Personified by the god Ra, the pharaohs drew their power from the sun, and together they ruled the ancient world in the timeless cycle of eternity. Their monuments still stand today. Each year at Abu Simbel, a remarkable event celebrates the anniversary of the reign of Ramses II. At sunrise, a stream of light penetrates the interior of the temple to bless a statue of the pharaoh. For 3,000 years, the Egyptians worshipped the power of the sun and kept faith in its enduring cycles. But on a distant continent, such reverence for the sun would take a prophetic turn. The Maya of ancient Middle America emerged from the shroud of time, a civilization awed by the forces of nature. Governed by superstition, they believed each movement of the sun was an omen of good or evil. To foretell the future, they built elaborate temples. This one, at Chichen Itza, was probably used for astronomical observation. Using fixed points, the sun's position in relation to the horizon could be calculated with amazing accuracy. For millennia, the movement of the sun would control the ritual and ceremony of daily life. But the ancient world would remain unaware that the power of the sun over destiny could be far greater than ever imagined. In the southwest corner of Colorado, in a seemingly inaccessible maze of canyons, is Mesa Verde, setting for one of the most unusual dramas in American history, the disappearance of an entire civilization. Carved in a cliff stands a citadel of stone, a human beehive built by a mysterious people called the Anasazi, the Ancient Ones. Today, Mesa Verde is a national park, a silent monument to the civilization that flourished here long before Columbus set foot in the New World.
You would have had a whole courtyard area, and it's out in these courtyards where these people did a lot of their work. They would make their pottery out here. The ladies would grind corn on grinding stones. The men would work with their bone and stone tools. You can imagine the children playing anywhere throughout the dwelling. The Anasazi did have domesticated dogs as well as turkeys, and from the evidence that we have, these animals were pretty much allowed to roam freely.
The Anasazi left no written record, but these ruins testify to their genius for survival. From their dwellings, they climbed the canyon walls to the mesa. Here, they would till the soil and plant squash and corn. Inventive farmers, they devised a complex system of reservoirs and dams to irrigate the semi-arid plateau where rainfall is sparse. For 700 years, the Anasazi thrived here, deeply rooted in the land. Then, mysteriously, they abandoned their tribal home. For those who listen, the walls still echo the past. Why they left is unknown, but an unfinished temple to the sun hints at a reason. The Anasazi worship the sun, but even their prayers may have failed to end a prolonged drought or an unusual time of cold. It is ironic that 7 centuries later, science is just beginning to investigate if changes in the sun could influence the Earth's weather. It is no mystery that the sun powers the oceans and drives the circulation of Earth's atmosphere. It creates our weather and, over time, the climate of planet Earth. For eons, the sun's output of energy has remained relatively constant, producing the patterns of weather and climate. But in the recent past, unseasonal changes in Earth's climate have raised provocative doubts about the influence of the sun. Can dramatic changes in the Earth's climate be linked to subtle changes in the output of the sun? In 1908, astronomer George Ellery Hale, working at the Mount Wilson Observatory near Los Angeles, California, made an important discovery about one of the sun's most intriguing features: sunspots. Long a source of curiosity, everything from baby booms to crop failures has been linked to their mysterious appearance. Then, in the 19th century, it was learned that sunspots come and go in cycles, every 11 years. Hale would show that sunspots originate in the sun's magnetic field, which reverses its polarity every 22 years. The discovery of the solar cycle seemed to confirm that the sun was a predictable star. More than 60 years later, Jack Eddy of the High Altitude Observatory still had a nagging doubt. The Hale Library in Pasadena, California, contains an archive of solar observations dating back to the 17th century. Nearly 100 years ago, another scientist, Walter Maunder, studied the same accounts of the sun and found that from 1645 to 1715, sunspots had virtually disappeared. His report, published in 1894, was scorned and forgotten until Eddy began his investigation. To him, the accounts of early astronomers are as valuable today as they were 300 years ago.
Rare old books, such as these, published more than 3 centuries ago, give us a direct record of what the sun was like in the past. This one was written by Christopher Shiner, a Jesuit priest, and published in the year 1630. It is this book, more than any, that convinced me that we could trust the astronomers of the early and middle 17th century, when their direct accounts, such as this one, showed us that the sun, at the time, was undergoing a major period of change.
During the so-called Maunder Minimum, the appearance of sunspots was so rare, they were often reported as new discoveries and became the subject of elaborate drawings. Digging further, Eddy found that the mysterious northern lights had also apparently vanished. These ancient books revealed that for 70 years there had been a major change in the sun's behavior. Though difficult for solar scientists to accept, proof would come from an unlikely source, not from the sun, but from the Earth itself. Trees are the oldest living things in the world. Their rings keep a diary of the sun's behavior by recording the amount of an isotope, carbon-14, in the Earth's atmosphere. The annual production of carbon-14 is directly influenced by the sun. Trees that were alive during the Maunder Minimum confirmed the dramatic change in the solar cycle. Now, tree rings are also being analyzed to find out if the presence or absence of sunspots can influence weather. For centuries, this ponderosa pine has struggled against the elements. The account of its survival in good years and bad has attracted researchers from the University of Arizona's Tree Ring Laboratory, Barry Richards and Charles Stockton.
Hey, Barry, let's try this one over here to the left. Yeah, looks pretty good. It's got a rather scraggly top.
In the past, tree rings have been analyzed to determine the severity of drought. But Stockton is more interested in the pattern of drought in the American West.
What we were doing was not really new. This had been done before. The thing that we were doing that was different was the fact that we were looking at many, many tree ring sites simultaneously, not just one.
To reconstruct the pattern of drought, Stockton chose some 60 sites across the United States, all west of the Mississippi. Here, drought conditions are prevalent and trees are more sensitive to subtle changes in the weather. Tree rings vary in size each year of their growth. They reflect variations in rainfall and temperature. One tree can preserve hundreds of years of climate history. A hollow coring device is drilled into the tree. Stockton and Richards must work fast. Within minutes, the tree will begin to heal. It will close in around the corer and make it impossible to remove.
Oops.
Got a snarled one, huh?
Yeah.
A steel rod removes the core.
Got the bark off, but
Yeah, it's got some variation in it. Looks good.
Tucked under the bleachers of the university's football stadium is Arizona's world-famous tree ring laboratory. Thousands of years of climate history have been assembled here using trees from around the world. Sanded, then mounted to highlight the rings, the core is placed under a microscope for careful analysis. Richards is looking for the lean years, for the narrow rings. Once the core is marked, the width of each ring is precisely measured and entered into a computer. The computer analyzes both the wide and narrow rings for significant patterns. It must then match the growth patterns from other trees to extend the drought profile back in time. Now Stockton is able to construct a series of maps showing how much of the United States is affected by drought year after year. The record goes back more than 300 years. When Stockton converts his maps to a chart of abnormally wet and dry years, a dramatic pattern of recurring drought becomes clear. These periods of drought have long been confirmed by history. In the 1840s, diaries of the pioneers told of the great hardships in the Trek West. Among them was drought. The 1930s saw America turn to dust, the worst drought in 300 years. It is American folklore that rain follows the plow. But 22 years after the infamous Dust Bowl, drought struck again. The cycle of recurring drought is clear, but its similarity to events on the sun went totally unnoticed until climatologist Murray Mitchell confronted Stockton.
Murray said, well, it looks to me like I can see a definite periodic tendency in the data. If you're not going to analyze it, will you let me analyze it? And I said, sure. We'll send you the data. So we sent the data, a large box of cards, to his office in Washington, D.C. And about 2 weeks later, we got a call from him, and he said, yes, there's a significant 20-year periodicity in the data, and I've already took the liberties of comparing it to the solar cycle. The two match up very, very well.
When the pattern of sunspots is plotted against the pattern of drought, the match is intriguing evidence the two may be intimately linked. For 300 years, the dramatic absence of rain has coincided with the appearance of sunspots.
One of the problems we have with the findings of our study is that many researchers, and rightfully so, think that perhaps what we're seeing is strictly coincidental. We really don't have a physical mechanism in mind to explain this periodicity. We really need to develop some sort of way of explaining how the change in the solar cycle might really be affecting the Earth's atmosphere, which ultimately affects the occurrence of drought.
If Stockton is right, sometime in the 1990s, the American West can expect the next episode in the provocative history that links sunspots to drought. To confirm the findings in tree rings, a longer record may be needed, a record millions of years old. Only then can the connection between a changing sun and the Earth's climate be fully explored. A prehistoric lakebed in South Australia may contain that record, a glimpse of the sun's behavior nearly 1 billion years ago. For years, George Williams has been combing Australia's rugged wilderness. An exploration geologist, he is looking for the natural resources of his native land. Today, Peachy Reachy Pass, north of Adelaide, is hot and dry. But 800 million years ago, it was covered by ice. Here, Williams stumbled on an extraordinary find.
These are very interesting rocks. They're siltstones and fine sandstones that were deposited in a glacial lake in pre-Cambrian time, about 700 to 800 million years ago. The fascinating thing about these rocks is the regularity of the banding. Both the half-inch banding and the millimetre banding repeat regularly in cyclic patterns which are quite extraordinary. It seemed to me when I saw these rocks that the regularity of the banding couldn't be explained by random earth processes. It seemed that some astronomical control was necessary to provide this regular banding.
Each summer, as the sun melted the ice, a new layer of sedimentation was laid down. If their thickness reflects temperature, it is an amazing record of the sun's behavior. Cores from the field are brought back to the laboratory for careful analysis.
This piece of core represents about 900 years of sedimentation, but it's still just a small part of the full sequence we hold in cores, which represent about 18,000 years. I'm holding in my hand a thin section cut from a piece of core. The section is cut by mounting the core on a glass sliver, and then the rock is ground down to a fraction of a millimetre in thickness until the rock is translucent. In this particular thin section, the dark bands are very clearly seen, and within the cycles, between the dark bands, are further bands, which I'm interpreting as yearly banding. The cyclic patterns displayed by the rocks match very closely the cyclic variations observed on the sun today. So it would seem that this ancient glacial lake was acting as a solar observatory and faithfully recording the fluctuations of the sun in pre-Cambrian time, many hundreds of millions of years ago. This is a very interesting observation and has important implications for our understanding of the modern sun. It indicates that the behaviour of the sun has remained pretty constant over hundreds of millions of years.
Our discoveries about the sun's ancient past are reassuring. Despite evidence that the sun may have caused drought, the fact is the global climate of the Earth has remained stable for thousands of years. But on the timescale of human history, civilizations rise and fall in a cosmic fraction of solar time. Though we have renewed our confidence in the sun, our search to understand its ultimate impact on the climate of planet Earth is only just beginning. The sun illuminates the darkness of space, some 93 million miles from Earth. In centuries past, the study of the sun has been a challenge to human ingenuity. One of the most fascinating early instruments of exploration was built here in Jaipur, India, by the 18th century Maharaja Jai Singh. It was one of the astronomical wonders of his day, a personal observatory. Looking more like a modern sculpture garden, this fabulous array of some 30 different instruments was designed for a single purpose: to calculate the motions of the sun and stars, from which the Hindus derive their intense belief in astrology. Many of the instruments are sundials, virtually giant clocks. The most impressive is the Samrat Yantra. As the sun moves across the sky, a shadow falls on two marble plates, each finely etched to mark the time of day. Incredibly, it measures time in seconds. Keeping time by the sun became a science for Jai Singh, but it tells us little about the sun itself. Seen with the naked eye, the sun is a vision of timeless perfection. But another instrument would extend our vision across interplanetary space and reveal a new and strangely unfamiliar sun. The Solar Telescope at Kitt Peak, Arizona, is the largest of its kind in the world. Inside, a series of mirrors captures the incoming sunlight and reflects it down a path 450 feet deep inside the mountain. What finally appears is a strikingly detailed image of the sun. 400 years ago, Galileo created a similar image with a primitive forerunner of the modern telescope. It was his observation of sunspots that shattered an age-old belief in the sun's perfection. Sunspots, like those being traced by scientist Keith Pierce, were our first clue that the sun is a changing and dynamic star. Later, telescopes would reveal still more dramatic features. They uncovered the existence of the sun's magnetic field, the source of its violent activity. They showed us changes in the sun's brightness and challenged the long-held notion that its output of energy is constant. And they allowed scientists to see the sun's outer atmosphere, the corona, an important link between the sun and Earth. Telescopes brought us closer to the sun and gave us our first glimpse of its dynamic behavior. But a second ingenious invention would take us beyond, to the surface of the sun itself. Beyond human vision, a single beam of sunlight contains a wealth of information about the sun. In the 17th century, the great physicist Sir Isaac Newton performed a simple yet elegant experiment to reveal the message in a beam of light. When sunlight is passed through a prism, it creates a rainbow of colors called the spectrum. What puzzled Newton was the nature of the spectrum. Was the image produced by the glass, or was it contained in the light itself? If the prism creates the color, a second prism should create still another spectrum. Newton found that light through the second prism stayed red. The individual colors of the spectrum could be separated no further. Newton's experiment would prove that white light contains all the colors of the rainbow. Light would become a tool for unlocking the secrets of the universe and form the basis of the modern spectrograph. Like a prism, a spectrograph separates each color of the visible spectrum. Seen in detail, hundreds of black lines appear in distinctive patterns. They are the chemical fingerprint of elements like hydrogen and helium, elements present in the sun. Called Fraunhofer lines, they would open a new frontier of solar exploration by revealing the composition, temperature, and density of the sun. Ultimately, we would learn that the solar spectrum also includes powerful waves of invisible energy, radio, infrared, ultraviolet, X-rays, gamma rays, and cosmic rays. Most are blocked by the filtering effects of the Earth's atmosphere. In 1973, American scientists launched the most powerful array of solar telescopes ever carried into space. Above Earth's atmosphere, Skylab would virtually peel away the sun's invisible layers to photograph its remarkable features. Enhanced by computer, subtle details become vivid images of high temperatures and magnetic turbulence associated with violent activity. An artificial eclipse reveals the intricate architecture of the sun's corona. Ultraviolet and X-ray telescopes record the eruption of a solar prominence and dissect it layer by layer. Skylab would capture details of the sun never seen before, images that would propel a search for the source of the sun's violent activity. It is one of the most hostile environments on Earth. A perpetual desert of snow where temperatures dip 100 degrees below zero. But for those who study the sun, Antarctica is a virtual paradise. At South Pole Station, summer begins in September. For 6 months, the sun never sets. Solar astronomers have long dreamed of observing the sun 24 hours a day. In 1979, the first solar observatory was established at the South Pole. In this crude-looking housing is all the precision required to track the sun continuously and obtain measurements of subtle changes on the solar surface. The need for continuous observation was brought home dramatically when Robin Stebbins and a team of scientists from the United States made an astounding find. While trying to measure the sun's diameter, they accidentally discovered the sun was quaking, virtually ringing like a bell. Just as earthquakes have long been a valuable tool for probing beneath Earth's surface, now solar oscillations may reveal the secrets of the sun's interior. Back at Sacramento Peak Observatory in the mountains of New Mexico, Stebbins employs a computer to diagram complex patterns of solar oscillations. Here, red represents parts of the solar surface moving away from us, blue moving closer. In a musical instrument, sound is made by a vibrating part, like the keys of a vibraphone or the strings of a bass. Our ears can distinguish the mellow resonance of wood or the cool ring of steel. Just as the sound an instrument creates tells us something about its composition and structure, the various patterns of solar oscillations will help scientists like Robin Stebbins fine-tune their theories about the interior of the sun.
There are over 10 million such patterns that are present on the sun. They're all present at one time, added together. From this great wealth of information, we can learn a great deal about how the inside of the star is put together and what it's made of.
Until now, the existence of sunspots and the strange behavior of the solar cycle have gone unexplained, their origins hidden deep in the sun's interior. Now, knowledge of solar oscillations may begin a new era of discovery. Of all the mysteries of the sun, one would remain beyond the reach of human knowledge until the dawn of the nuclear age. The sun is a dense ball of gas. Deep in its core, a thermonuclear furnace continually fuses hydrogen into helium to yield a seemingly inexhaustible supply of energy. Moving outward from the core, densely packed atoms collide and release energy that is radiated toward the surface. Near the surface, gases from the interior are reheated and transported by convection to the photosphere, the visible face of the sun. Here it displays its most spectacular phenomena. Above lies the chromosphere and the corona. Larger than the sun itself, the corona stretches thousands of miles above the surface. Here the sun boils away its outer layer and spews it into space. Far from empty, the region between the sun and Earth is filled with star stuff, fragments of the sun itself, charged particles called plasma. It is the lifeblood of the universe, the most common form of matter. Plasma flows through interplanetary space at 1,000,000 miles an hour to become the solar wind. The discovery of the solar wind would prove a vital link between the sun and planet Earth. Perched high on a mountaintop on the Papago Indian Reservation in Arizona, Kitt Peak Observatory is host to scientists from around the world. Today, researchers from West Germany, Great Britain, and the United States will attempt to create and photograph the world's first artificial comet to learn more about the solar wind. Gerhard Herrendell of West Germany's Max Planck Institute heads the effort. In a few hours, he will order the release of 2 canisters of barium from a satellite orbiting 70,000 miles above the Earth. His objective is to simulate what happens when plasma from a hot star, like the sun, hits a cold object like the Earth.
The experiment which we hopefully will see if the sky will be clear on the morning of Christmas Day is the very first in its kind. We have started to develop this technique of throwing a dye into a cosmic plasma already 20 years ago, but we have never had the opportunity to get out of the Earth's magnetic field, way into the solar wind, and also to fly it on this experiment on a spacecraft which is equipped with a lot of detectors.
A second satellite, operated by a team of British researchers, trails behind. Equipped with sophisticated sensors, it will actually fly through the tail of the comet.
So in this configuration, this is completely new. We have not done it before. Nobody has done it before, and so it's very exciting.
30 years ago, space was considered a vacuum, except for a curious clue, the tail of a comet. Regardless of the direction it traveled, its tail always pointed away from the sun. A mystery unexplained until the discovery of the solar wind. By late afternoon, clouds obscure Kitt Peak. For the experiment to succeed, Herrendell must have 3 observation points to locate the comet in space. He has already lost 1. In addition to Kitt Peak, cameras have been set up in New Mexico, Hawaii, and aboard aircraft in Tahiti and California.
So, any change?
Werner? Ja? Was hat denn der Franz für eine Bildwiederholzeit?
Listen, Paul, it's extremely important. We have to have a rather reliable prediction from you, because now we would only have you and the Southern Pacific aircraft. There's no other station clear. The Convair 990 did not get off the ground. Did I tell you that? I think so. Without the NASA aircraft, I would be very hesitant. See, if anything goes wrong somewhere, then we lose our triangulation possibility. Okay, Mike? Yeah, we just scrapped it. White sands is not really quite clear. Yeah, right. Okay. Well, same to you, Mike. I'm sorry. Good. One day we'll get a winner, okay? Yes. Bye-bye.
2 days later, all the observation points are clear. A specially equipped aircraft from NASA's Ames Research Center in California makes a second attempt to record the comet.
15 seconds. 10 seconds. 5, 4, 3, 2, 1.
Yeah, Germany confirmed release as well. And that's the object right there. I saw it blue, bright out, that big bright object on the screen. The brightest thing you can see, I think, isn't it?
It is. It's at left center.
Yeah.
About halfway between center and the left edge.
Roger.
Seems to be holding or shrinking.
712 over. Kitt Peak, we have a comet. We have the comet. It is on tape. Over.
That's impressive as hell.
It's out the window. It looks more like about 4 or 5.
Okay.
I'm not very well dark adapted.
Can anyone see it with naked eye? Yeah, I see it.
So, okay, what do you make the tail orientation?
Well, we have it here, the tail is coming. The tail is coming up here towards the top. It's very faint here in this image, but it's there.
This vivid image was captured over the South Pacific. It was hoped that the comet would be visible for an hour, but after only 6 minutes, it vanished, blown away by the unpredictable speed of the solar wind. The behavior of the comet is important to understanding the impact of this powerful force on an invisible envelope around the Earth, the magnetosphere. Like the sun, the Earth has a magnetic field believed to be the result of electrical currents generated deep in its core. When Earth's magnetic field interacts with the solar wind, it forms a shield. It also forms the shape of a comet. The magnetic field facing the sun deflects the solar wind around the Earth. It bends the Earth's magnetic field into a tail that stretches 1,000,000 miles into space. The only visible manifestation of the solar wind ripples across the polar sky like an eerie veil, the aurora borealis. For more than 1,000 years, songs have been written to it, children named after it, poetry inspired by it. Some say the northern lights are the glare of Arctic ice and snow, and some say it's electricity, and nobody seems to know. In his famous Ballad of the Northern Lights, Robert Service, the poet of the Yukon, describes the mystery that has baffled mankind for centuries. Rarely seen in Europe, the appearance of an aurora in 1570 is vividly chronicled in a medieval manuscript. The town was illuminated as if it were ablaze. When the people saw it, they were horrified and said that no such gruesome spectacle had ever been seen or heard of within living memory. In Alaska, where the aurora is commonplace, few fear it. But William Tyson is an Eskimo, and he does. Some Eskimos carry knives to protect themselves.
We're scared of them, and we respect them, because they can come down and take the people away from the earth. And if the aurora come down and take the people, that person will never appear again. Before the Second World War, for 1 year, all winter long, we sat there. Anytime we see the aurora, they'd start getting red from the west and up almost halfway, and then change color again. That happened all winter long. And then in the fall, the war broke out. Then my grandmother told me that anytime the aurora get red, there's going to be a lot of bloodshed.
Just 30 years ago, the upper atmosphere was inaccessible. Now an arsenal of scientific weapons stands ready to explore the mysterious aurora. "30 miles north of Fairbanks is a unique research facility, the University of Alaska's Poker Flat Research Range. When intense auroral activity is expected, preparations begin early. A 3-stage rocket is carefully moved to its launch pad for assembly. The procedure is time-consuming and can be dangerous. The payload is a 9-inch explosive charge. It will eject a tracer of barium into the aurora. The accuracy of the rocket is dependent on the wind and the weather. A balloon is released every hour to track minute changes in wind speed and direction. By nightfall, preparations are complete. Eugene Westcott of the University of Alaska will monitor the rocket launch and the barium release. If all goes well, one more chapter will be written in the search to understand the dynamics of this remarkable event.
By putting up a barium release, which is like a tracer, like putting dye into a stream, we hope to understand more fully the electrodynamics of what's going on. If we're lucky, we'll see something that we've never seen before that'll give us a deeper understanding of really what's going on.
FAA, this is Poker Flat. We're at T-minus 5 minutes, and we'd like to pick up the count. Could I have clearance, 20 minutes clearance in Zone 1 West, please? Thank you.
Westcott has been carefully monitoring the aurora. Now he will decide whether to proceed with the launch.
Okay, Pat, we'll go.
On my mark, we'll be at T-minus 20 seconds and counting.
Roadblock 1 and 2, we're at 20 seconds and counting. 20 seconds.
10, 9, 8, 7, 6, 5, 4, 3,
All right, I'll be
2,
off the net.
1, launch.
As the rocket intercepts the aurora, charged particles hit the barrier to illuminate the night sky. 30 years of experiments like this have finally revealed the origin of the aurora. The solar wind acts like a generator. As it strikes the magnetosphere, it discharges billions of watts of electrical power. The energy flows down Earth's magnetic field lines toward the poles. As it hits the upper atmosphere, it begins to glow like a halo of fire to form the aurora, a permanent feature of Earth's atmosphere at both the north and south poles. Recently, a unique instrument designed by the University of Iowa was flown aboard a polar orbiting satellite, the Dynamics Explorer. The result, this breathtaking time-lapse image of the aurora borealis, seen from space for the first time. In another laboratory at Poker Flat, an even more dramatic experiment is underway. A system of extraordinary television cameras, sensitive enough to see the glow of a cigarette 5 miles away, will attempt to record tonight's aurora. Violent and elusive, it is difficult to capture. But Shun Akasofu and his associate, Dan Osborne, have perfected the technique. Television cameras are the latest tool for detecting the subtle features of an aurora. They also enable us to witness, in real time, the most dazzling light show the world has ever seen. Much has been learned about the aurora, but a key question remains. Exactly what happens when billions of watts of electrical power are pumped into Earth's atmosphere? In Boulder, Colorado, the Space Environment Service Center monitors the sun 24 hours a day, 365 days a year. A global network of telescopes and orbiting satellites watches the sun for changes in its behavior. When solar activity begins on the sun, time is critical. Warnings are immediately issued to the Department of Defense, NASA, and to airlines that fly the polar routes.
At this time, I would like to issue an alert for an X-ray event.
8 minutes after the eruption of a solar flare, a blast of X-rays and high-energy radiation tears into Earth's upper atmosphere.
We would expect protons to accompany this event within the next 48 hours.
Protons are accelerated by the solar wind. In hours, they will bombard the upper atmosphere to create a storm in the Earth's magnetic field. During a proton event, shortwave radio signals can be blacked out for days. Telephone circuits can experience overloads, and power stations a surge in electrical currents. Ironically, Skylab, which had given science so much information about the sun, tumbled prematurely from space in 1979 because of the sun. It was solar activity that heated and expanded the upper atmosphere to increase the drag on the spacecraft. Its orbit decayed, and the friction of Skylab's rapid descent turned it into a blazing hail of fire. The early demise of Skylab was a valuable lesson. The sun has now become a critical factor in the design of spacecraft. In the near future, 6 astronauts will live and work aboard a permanent station in space, vastly safer than a decade ago. Under the blanket of Earth's atmosphere, most of us are unaware of the potential dangers of solar activity. Like the people of the ancient world, we too worship the sun, each in our own personal way.
City and the valleys are peaking around 102. And now for the moment you've all been waiting for. Let's turn so you don't burn.
Unfortunately, we have recently discovered that the sun can be hazardous to our health. Excessive exposure to invisible ultraviolet radiation is the primary cause of skin cancer. 15 miles above Earth, the sun interacts with the atmosphere to create a protective shield called the ozone layer. Ozone protects us from most ultraviolet radiation. Although the sun steadily creates ozone, scientists have recently discovered that violent outbursts of solar activity can also destroy it. A scientist from the National Oceanographic and Atmospheric Administration witnessed just such an event. George Reed.
In August of 1972, we observed the most intense solar flare we've seen in the 30 years or so since we've been studying these events. For the first time, we could observe directly how these events can weaken our protective ozone layer by introducing nitric oxide, which is a powerful chemical destroyer of ozone.
At the University of Colorado, concern over this dramatic discovery has prompted a unique experiment. Students are manning a satellite, the Solar Mesosphere Explorer, launched by NASA in 1981.
We are now transmitting sensitive commands to the spacecraft.
A virtual laboratory in space, the satellite is monitoring changes in ultraviolet radiation and ozone. Early results from the satellite have confirmed the direct link between the destruction of ozone and the increases in nitric oxide produced by ultraviolet radiation. We now know that the ozone layer is far more delicate than we ever envisioned. The balance between its creation and destruction took billions of years to evolve. The question now is, can man destroy that delicate balance?
By changing the atmosphere through his industrial, agricultural, and chemical emissions, can we severely damage our protective blanket? How far can we go before the ozone layer is seriously depleted? How can we be sure of these things? These are questions to which scientists are only just beginning to find the answers.
A profound revelation of the 20th century is man's impact upon his global environment, one that may now touch upon his relationship to the sun itself. Still, the affairs of man are but an epilogue to the history of Earth. Billions of years ago, the sun cast its control over planet Earth, setting the stage for evolution. Only now are we beginning to grasp the full dimensions of its incredible power. For the first time, we have seen it from space, awed by its violence and imperfection. We have probed its surface, and beneath found infinite rhythms and subtleties that shake our confidence in its reliability. We have explored the invisible realm of interplanetary space and expanded our earthbound vision of the solar sea. Yet we have found visible proof that although the sun is ever-changing, it has never endangered life's delicate foothold on planet Earth. Our connection to the sun goes far beyond what we ever envisioned. 1,500 light years from Earth, in the Orion Nebula, stars much like our own are being born, and with them the ingredients of living matter. The chemical elements of life have their origin in the living and dying of stars. Born to planet Earth, we are truly children of the sun. Our link to the stars was forged from the beginning of time.
Annenberg Media. For information about this and other Annenberg Media programs, call 1-800-LEARNER and visit us at www.learner.org.